I've got an update on the main board of the recreation, and the problem I had, or the only remaining problem as opposed to things I hadn't implemented, was the power. So over here I've got you've got power coming in here, which then there's some regulators which then get power to the 12 volt boost converter here. That's for the OLED display, so you need 12 volts to drive that. And what I found was when everything went off, there's a whole load of transistors here which control the power. There's various inputs and so on which can turn the power on and also allow the power to be turned off. So the Pico can turn the power off and on. The real-time clock can turn the unit on. You can only turn off if all the inputs saying turn on are also not asserted. So you can turn it on with the Pico, the real-time clock, also the top slot over on the power board. You can come in here and turn it on. And what I found was that this transistor circuit here, even though all the inputs said I don't want the power on, there was a small amount of voltage going into the input of the 12 volt boost converter, and that was enough for this to run and generate about 2 volts, just under, between 1 and 2 volts. And I couldn't work out what it was. There's a transistor here in this section here underneath the flex cable. There's more transistors and diodes. There was a transistor there which, as far as I could see on my multimeter, should be off, but it was slightly on. So I was looking at the circuit and trying to work out what was going on. Obviously, when you've got this 12 volt boost converter running, you're going to be draining the battery while the thing's off, so that's not ideal. And I was trying to work out what was going on, and then I realised that it could be switching noise from the 12 volt boost converter going back and somehow getting into the gate of that MOSFET, and that would be causing it to turn on briefly. So it wouldn't be a DC voltage that was coming out, it would be an AC voltage. Now I haven't checked that with the scope, but what I did, I put some capacitors on the MOSFETs to block the high frequency noise, if there was any, which was going into the MOSFETs and turning them on and allowing this to run. So I mean, that isn't going to hurt. In fact, I'm probably going to add those components anyway, because it's going to be a good idea to do that. This power switching circuit basically runs at DC, so we don't need any high frequency at all. I mean, obviously you do, but you need to turn the thing on, but I'm not interested in it switching at high frequencies. So that would sort of explain why, when you turn it on and attach the battery initially, the DC boost converter is off. You turn it on, the boost converter runs. You turn it off and it doesn't switch off properly, and I think that's because the boost converter noise was going back into the MOSFETs and holding them on slightly. That sort of makes sense. You've only got the noise once after you've been on. You haven't got the noise when you initially switch on. So I put those capacitors on and it didn't work still, but the reason for that was much more straightforward, although a little bit strange, in that the real-time clock circuit was holding its on signal in the on state. Now that's odd because, first of all, the resistor that is pulling up the open collector that's coming out of that real-time clock was wired to the wrong supply. It was wired to 3.3 volts, which is off. So you can't turn the thing on with a supply and pull that line up with a supply that isn't there because the machine's off. So I've rewired that. We do have a bodge wire now, unfortunately. I've rewired that to V battery, but it was still high, so the chip wasn't actually pulling that low, and that was holding the unit on or turning the unit on. And that's odd because I'm sure I changed the code to make that a low signal when the thing's off, or well, when I set the chip up I just make it low. I haven't written the alarm code yet. So that was odd. So for the moment I've disabled that. I've pulled the resistor out, so that just stays low. And now this unit works. So I think a combination of putting those capacitors on and fixing this problem means that this is now working. So unfortunately it means I'm going to need probably a new PCB with some modifications around here. Otherwise you have a bodge wire here and some capacitors soldered on top of resistors. So it's not a disaster. I mean, this is easy. It's easy to modify those things. So I need to sort out the real-time clock signal. But now I think the power problem, I think that may, well, I'm not sure it's entirely solved because I'm still not 100% certain what the problem was. But I've got a pretty good idea that it's a combination of this and probably noise going into that transistor. I had some weird stuff going on with the transistors, where there were transistors that should be off and they weren't, they were on. So I might put the scope on it, but now as I've got it's about 700 microamps now when it's off, so it's still pretty high. I've got a few resistors that are pulling things up that need to be certain values. The real-time clock is a bit of a problem because of the current that requires to run when it's on battery. You actually need some pretty low value resistors across the supply, so that's a bit disappointing. So you can get the supply current down, but it's not going to be ultra low power. But then this whole recreation isn't ultra low power anyway. I mean, you can switch the thing off. You can actually disconnect the battery, and you've still got your data stored in the flash chips over here. So it's not the same model of low power as the original organiser at all. I mean, obviously when it's running, because this is an emulator, there's higher power there as well. But yeah, so much happier now that the power supply circuit is probably more or less okay. I just need some more components and fix this, and we can move on.